In this video, the 11th in the Getting Started series, we will learn how to assemble our components together and learn some additional functionality such as joint command, as-built joints, rigid groups, constrain components, motion links, and insert fasteners. Now that we've created a majority of the models in the design, we want to start assembling them together. Start by expanding open the data panel and opening the fishing reel assembly. With the data panel still open, right-click on the spool in the data panel and select Insert into Current Design. The spool will appear at the bottom of the fishing reel, so drag one of the translation arrows to move the spool off to the side and press OK. Refer to Exhibit 1. We want to move the spool to a very specific position, so we will use the Joint command to accomplish this. From the Assemble menu, select Joint. Zoom up on the top of the spool and hover near the slot. You will see many tick marks signifying center points, midpoints, and endpoints. Trying to pick the correct one can be challenging as you move your mouse. Here's a neat tip. Hold down the Control or Command key to control your selection, and it will only allow you to pick the tick marks on the face when you held down the Control key. Click on the center point in the middle of the slot. Refer to Exhibit 2. Zoom out, then zoom in on the bottom threaded area of the shaft. Hover over the flat face at the bottom of the threads. A tick mark will appear at the center of the shaft. Hold down the Control key and select the center mark. Refer to Exhibit 3. The spool will move from the original location to this new location. It may end up flipped in orientation. If so, just click the Flip option in the Joint dialog. Click on the Motion tab in the dialog to confirm that the motion type is set to Rigid. The top center of the slot on the spool is now rigidly connected with the center of the flat face of the shaft. If we rotate the bail, you will notice that the spool and the shaft rotate together because they are rigidly connected. However, you will also notice that the bail wire is not rotating with the assembly as we would like. With the bail wire in its current position, we can utilize the As-Built Joint tool. This tool, found in the Assemble menu, allows us to define a joint type without the need to reference tick marks. Select As-Built Joint, then choose both the bail wire and the small black bail arm. Ensure that the motion type is set to Rigid, and then click OK. Now, when the bail rotates, the bail wire will move in conjunction with it, thanks to the rigid as-built joint. You will notice a chain link icon next to the spool and some other components in the browser, indicating that they are referenced designs. This means that you can't directly modify them, for example, by adding a fillet or a chamfer. To make changes, you'd typically open the original model, make and save your edits, and then the update would reflect in this design. Alternatively, Fusion offers an Edit in Place feature, allowing you to make changes directly within this design, and saving it will also update the original spool design. Access the data panel and insert the Handle Start subassembly. Observe that currently there are no joint relationships between the components when attempting to drag them. To connect the handle and the shaft, use the Rigid Group feature from the Assemble menu. Select both the handle and the shaft, but do not include the end cap at this time. Now, moving the handle will also move the shaft. To position the handle, we will use the joint command again. This time, use the J shortcut key to run the joint command. Select the outside circular edge of the handle, and then the circular edge on the reel. You may need to flip the alignment. Set the motion type to revolute. Refer to Exhibit 4. The Constrain Components command is ideal for keeping the hexagon face of the end cap aligned with the hex shaft. To do this, go to the Assemble menu and select Constrain Components. Then, select the top inside face of the hex hole in the end cap and the top face of the hex shaft. This action will ensure that these two faces remain planar. Refer to Exhibit 5. Next, click the plus symbol in the dialog to add another constraint. Select the circular edge of the end cap and the circular edge of the reel where the end cap would sit. This creates a revolute relationship between these two edges. Refer to Exhibit 6. Rotate the end cap and notice that the handle rotates also as it's connected to the shaft that the end cap now has a relationship with. We want the bail to rotate when we crank the handle, so we can link the two together with a motion link. In the Assemble menu, select Motion Link, and then select the revolute joint on the handle, and then the revolute joint on the bail. The preview will show the two joints linked together. We want the bail to rotate clockwise as we rotate the handle clockwise, so click the reverse option in the dialog and press OK. Now, crank the handle in the viewport and notice the movement on the screen. We can also change the gear ratio of the spool by editing the motion link. Right-click on the motion link in the timeline and select Edit Feature. Change the angle of the first angle dialog to 90. This means that for every 90 degrees we turn the handle, the bail will turn 360 degrees. Press OK and crank the handle and notice the difference in rotational speed. Insert the handle grip into the design and drag it off to the side. Create a revolute joint between the circular edge of the handle grip and the circular edge of the handle. To hold the handle grip in place, we need to insert a fastener. From the Insert menu, select Insert Fastener. From the Standard pull-down, scroll down and select Metric under the Unit System. This will filter out all of the other fasteners and only show the metric fasteners. Then, click on Bolts and Screws, then Round Washer Head. The dialog will now show all of the metric round washer head screws that are available. Let's filter our selection even more and select just the ISO standard from the pull-down. Now only the metric ISO round washer head screw is displayed. Click on it to select it. Refer to Exhibit 7. Hover over the hole in the handle, and the appropriate fastener size will automatically be selected. Click to place the fastener, then set the nominal length to 16 and click OK. Observe how the fastener automatically creates a rigid joint when you rotate the handle. The last part is to assemble the tensioner at the top. Upload the tensioner file from the exhibits into the project, and then insert it into the design. Drag the tensioner up above the whole assembly and press OK. Again, we want to line up the flat faces of the screw shaft with the tensioner, so we will use the Constrain Components one more time. Select the side flat face of the screw hole on the tensioner, and then the side flat face of the shaft. Press OK, and drag the tensioner up further if needed. Edit the Constrain Components feature in the timeline and add another constraint. Select the inside bottom of the screw hole on the tensioner, and then the top face of the shaft. The tensioner will snap down into place, however, it is not yet centered. Add a final constraint and select the outside cylindrical face of the tensioner and the inside cylindrical face of the spool. Press OK and then rotate the handle. The tensioner will rotate with the spool. If you want to toggle the visibility of the joints on or off, you can select the Display Settings icon and then Object Visibility, Joints. Now when we rotate, the joints icons do not display. Go to the File menu and select Save As and type in Fishing Reel Assembly to save this as a new file. In the next video, we will cover the data panel and collaboration.